Welcome to the Stormsurf video surf forecast for the week starting Sunday, November 4th. Looking at significant wave heights for the North Pacific Ocean, we see an area of 23-foot seas in the northern Gulf of Alaska, part of a small gale that developed on Friday and is traversing to the east, eventually expected to push into central Canada, and perhaps producing some minor swell for the North Pacific Northwest down into California, but nothing significant, and a tiny area of low pressure producing 18-foot seas aimed somewhat at Hawaii. But overall, pretty quiet pattern is in control at the moment. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough or a dip in the jet, just like that right there. Now this is a very small trough, pinched, not a lot of room. You really want something a little bit more expansive, and there is hardly any wind pushing down into the west side of the trough. That's the important side, and all the wind energy is over on the east side. So when you have wind on the west side, that helps support north to northwest winds in low pressure that would typically form here. But when the winds are, all the high winds are on the east side of the trough, all that does is support winds pushing up the cold front typically associated with these lows, and all that energy is, of course, aimed to the north at Alaska. It does nothing for our main forecast area. Anyway, so this trough here, as we said, pretty small, not super impressive. All the wind energy in the wrong spot. Also notice that the jet is ridging to the north off of California here. That helps set up high pressure aloft, and that doesn't do anything to produce swell. Also notice the jet pushing off of Japan here is well split. Between the split jet stream flow, you typically get high pressure as well. So high pressure, tiny little low pressure area, another area of high pressure, and kind of just not a good pattern right now that we're in. But we think that hopefully will be short-lived. We believe this situation right now is because the inactive phase of the jet stream is over here developing in the West Pacific, and that typically steals energy from the jet stream. And when you have lack of energy, as you can see right there, there's the last bit of energy in the jet. It's pushing off to the east. When you get lack of energy, you get a split pattern, and you don't get much support for gale development. All right, let's roll this out, see what's forecast. Sure enough, that little low just completely disappears. The jet gets completely split, and just a bad pattern, only getting worse as we get into Tuesday night. All the energy disappears from the jet. It's just sort of a jumbled mess. No clear support for any gale formation, and that continues into Thursday, and then theoretically, this pocket, so this just showed up on the latest run of the model, maybe this morning a little bit. An area of, what is that, about 110 knot winds develops Friday night into Saturday, sort of trying to build a little bit of a trough right here in the western Gulf of Alaska Saturday night. There you go. Then you get up to 130 knot winds. This is looking a little bit more like a normal kind of trough here. Still, jet's kind of split. The only reason we're getting these winds here is it sort of pulls together right in this area. So maybe some support for gale formation in the Gulf as we get into Sunday, but that's a week out. We never believe a model that far out. Anyway, that's supposed to hold into maybe Sunday night or so, and then kind of starts fading. You see, you get this definite sense the jet is split back over Russia. Again, not a whole lot of real optimistic looking picture right now. All attributable to the inactive phase of the MJO. So let's see what effect that jet is going to have down at the surface. Ocean surface level pressure, surface level winds, as expected. There's high pressure off the coast of California. Remember, the jet's going up like this. 1028 millibar high, creating north winds along the California coast, making for some wind swell. Also making for trades, pushing into Hawaiian Islands. This almost looks like a summertime pattern, but here we are in the first week of November, and really no sign of fall has yet happened. Yeah, there's been one or two swells into Hawaii and one or two weaker swells into California, but just nothing particularly stellar going on. Roll this out. Little low pressure there north of Hawaii continues into Monday. 30-knot winds. You're not going to get much from that. You really need at least 35-knot winds. High pressure setting up over the dateline, 1032 millibars by Tuesday night. That's not good either. Low pressure way tucked up in the northern Gulf. Another low, a gale low, but it's in the Bering Sea behind the Aleutian Islands. No swell generation potential from that. And you just see high pressure off the California coast. Maybe some wind swell there as we get into Friday. But this is just then finally, theoretically, if a trough develops, we'll just roll it back. There we go. Yep. Come Friday night, small area, 45, 50-knot winds, but we're 132 hours out on the model. Not believable. That gale, actually, it was a storm. If you have 50-knot winds, that's a storm. Down to 45 knots to get into Saturday morning. Looking good per this, and continuing into Sunday in the Gulf of Alaska. This would be a definite swell producer for the U.S. West Coast and also somewhat for Hawaii, but it's 132 hours out from even forming. It's only been on the model maybe 1 or 2 runs. I would view this with a heavy amount of skepticism at this point in time. All right, so let's go take a look at the effect of those winds on the ocean surface. But before we do that, we're going back in time. Friday, 2 days ago, a broad, ill-formed area of low pressure. We're not even going to call it a gale. Developed here over the North Dateline region. And a small area of 22-foot seas, 23-foot seas to be specific, developed Friday morning out of that. Kind of aimed more to the northeast. But then as we got into Saturday, looking a little bit better, 25, well, we'll say 24-foot seas right here in this area. And then that, as of 18Z, there we are. That's where it is right now. And is forecast to track to the east, here we go, into Monday morning and dissipate. So some small swell. So it basically ran from somewhere over here across basically to the east. Really no swell pushing south towards Hawaii. Yeah, maybe a little tiny fragment of swell energy, but mostly for the Pacific Northwest, maybe down into Central California. But the other side is there's supposed to be north winds still blowing, a bunch of wind swell, and you probably won't see a whole lot from that gale in terms of swell. Okay, and so we're looking for the future. We know there's something scheduled as we get 132 hours out. So we're almost there. There we go. Small area 20-foot seas at Saturday morning over the in the northwestern Gulf, building to 32-foot seas and holding into Sunday or so, then fading out some, only to rebuild into Sunday night into Monday with 30, what's that, 30, 32, 34, 35-foot seas, let's say. So if that were to happen, yes, it looks great. We have zero confidence in that right now, just given the way things are. But it's a nice little tease, something to monitor, something to hopefully keep your spirits up till the active phase of the MJO materializes in the West Pacific. So in typical summertime fashion, if there isn't swell, we look for wind swell. And we see east trades blowing over the Hawaiian Islands, 15 knots, maybe good for some small east wind swell on the east-facing shores. And then, of course, the standard gradient along the North California coast, north winds 20 knots or so. There were waves shoulder to head high in Northern California today. Not good, but there were waves. And about the same thing. Saturday was better, less local near shore wind, made for maybe slightly overhead waves at OB on Saturday. Anyway, so let's see where we're headed here. Monday, gradient continues, not so much for Hawaii. North winds 25 knots along the North California coast, building to 30 knots in the afternoon, late afternoon. More wind swell down into Central California. That continues, sort of fades some on Tuesday. Less winds locally. Little gale maybe forecast for the Gulf. Tiny area, 35-knot winds. They're probably not doing a whole lot. Wind swell continues for Northern California. Then we get into, where are we? We're into Thursday still. More wind swell for North and Central California. Now notice this. So what is this? This looks like high pressure developing here. North winds aimed at Hawaii. Maybe some short period north wind swell kind of thing going. So we get developing into Friday. Now finally, as we get into Saturday, low pressure. No high pressure, no strong high pressure along the California coast. Wind swell disappears for next weekend, theoretically. Hawaiian Islands getting a good dose of northwest winds just north of the islands. Good for wind swell there. And then we have, of course, our broad gale, if not a storm, in the Gulf of Alaska, theoretically. And then that's it. So wind swell for California till about you get to the weekend, and then that's over. And then the wind swell focuses on Hawaii, but also probably a bunch of wind at all the exposed breaks, so not great conditions. And just a quick look at at precipitation potential for, let's say, the northwest United States. The focus, Whistler's got some snow up high, up at the crest there, but not a whole lot. In fact, nothing down in the valley. And still kind of early in the season, looking high pressure, not seeing a whole lot going on. And there you go, high pressure blocking everything for California still. Again, there looks like maybe some potential for more frozen precip into Whistler in that area, British Columbia, as we get a week out. Oops, and that's it. That was at a week. So still nothing for California, nothing for Oregon yet. If this system develops and is strong enough, maybe it'll help push the zone. Right now it's pretty much all focused up here, British Columbia, maybe Washington, maybe nudge that a bit further south. Still a bit early in the year, though, for snow in the Sierra. All right, let's take a look long term. What's going on with Madden-Julian oscillation and with a potential developing El Nino? As usual, we'll start looking first the Madden-Julian oscillation. When in the active state, that helps fuel storm development and imparts wind energy to the jet stream. The jet stream, of course, when it has more wind energy, is not split; it's consolidated. Then you start getting more defined troughs, and you start getting storm development over the dateline in the western Gulf of Alaska, and that, of course, makes surf. And as the MJO travels it's on the equator from west to east, and as it starts moving closer to California in the active state, then sometimes that will push precipitation and the storm track and the jet stream right into California and create snow and all kinds of inclement weather, which would be a good thing. Of course, in the inactive state, the MJO over here causes the jet stream to split and not have any energy associated with it. And as it makes its trek across the Pacific, it does the same thing relative to California. Typically takes about 4 weeks to go from, this is New Guinea here, far west Pacific, to a point south of California. Actually, that'd be right here. About 4 weeks, something like that. So 4 weeks active, 4 weeks inactive, back and forth it goes. All right, right now, looking at winds across the equatorial Pacific. There's the equator, West Pacific here, East Pacific there. That's New Guinea. We see it in the arrows. We're just looking at the arrows. Winds blowing solidly from the east, but a lot weaker as you get into the West Pacific. Some of the sensors are out down here. That's why it's white. But you still get a sort of sense of what's going on. But then, well, is this stronger or weaker than normal? We look at anomalies, differences from normal for this time of year. You see that actually these winds are weaker than normal because you get these kind of it's blowing out of the west, meaning westerly anomalies the whole way across the Pacific. That's kind of a good thing, especially when you have a erupting Kelvin wave in this area. That suppresses cool water from developing on the ocean surface, actually lets the Kelvin wave fully bloom and build a warm water pool. And you can actually look at it 1 degree above normal in this area, maybe 1.5 degrees right here. That's when we're talking about El Nino. That's what you get. If you were talking La Nina, you'd see negative temperatures below normal in this area. We also see westerly anomalies, almost to the date line, and then weak easterly anomalies. See these arrows here? That's sort of an indicator, and specifically in the West Pacific, of the inactive phase of the MJO. So what's been the trend the past 5 days? Well, there's South America there. There's New Guinea there. There's the equator. We're looking Kelvin wave generation area. This is the main area in the West Pacific we're really interested in, from 170 west to 135 east, 5 degrees north and south of the equator. When the active phase or inactive phase, the MJO, is in this area, that's where it has the most influence on the jet stream in the North Pacific and in the South Pacific in southern months. or in summer months. And right now we see this was as of October 29th, kind of a mixed bag. We're looking at the arrows right in this little box right in here. We see kind of not really west anomalies, not east anomalies. And that sort of continued on the 30th. And we're just looking, and then we got the blues developing on Halloween. East anomalies building and building more as of a day or two ago. This clearly is an indicator that the inactive phase of the MJO is straddling the equator right in this area over the maritime continent, starting to push out into the West Pacific. If you remember looking at the jet stream charts a week from now, they were pretty weak north of this area, all scattered and torn apart. That is likely because of this here. Zonal wind anomalies, the forecast for the next week. First, we look at a little bit of past performance. So this is the whole planet on one chart. The blues are easterly anomalies. The reds and purples are westerly anomalies. The date line runs right down the middle of the chart. So the Kelvin wave generation area is basically between these two tick marks. And you just sort of get, this is October 5th. So you can see we had a bit of a westerly wind burst associated with the active phase of the MJO here in mid-October, up until Halloween, basically. And then the past 4 days or so, here was this building easterly anomaly pattern. You go, wow, that doesn't look good. But the good news is, it looks like it'll go for another, 4 or 5 days, and then pretty much fade out, sort of retrograde east and move inland over the maritime continent while we get some westerly anomalies building in the core of the Kelvin wave generation area. Nothing too particular strong. We also see more easterly anomalies developing on the dateline, in the dateline area. So it looks like the inactive phase of the MJO is going to hold for the most part for at least the next week, even though some westerly anomalies are going to try to get a toe in the door. Probably will not have much of an impact. Let's look further out. All right, so what's the state of the MJO? If you see, this is outgoing long-wave radiation. That is sunlight reflectivity off the ocean's surface. The more of it you have, positive numbers are the red, means high pressure, means clear skies. That means the inactive phase of the MJO. Where you have less sunlight reflectivity off the ocean surface, like here, negative numbers, that means more clouds. That means the active phase of the MJO. So the active phase of the MJO is moving into the Indian Ocean. The inactive phase is moving into the West Pacific. We go out 5 days, more of the same. The weakening. Go out another 10 days. You go, hey, it almost looks like the active phase of the MJ is moving into the West Pacific. And per this model, the statistic model, by 2 weeks from now, the inactive phase of the MJO is gone. Active phase is in the West Pacific. And theoretically, then the jet stream would be waking up, and then our storm track would be improving. Would be, maybe. But there's another model we have to contend with, the GEFS model, dynamic model. It's basically showing the same thing, but then you get to 2 weeks out, and it shows the active phase not as strong moving into the West Pacific, but generally, not too far off. Either way, the inactive phase of the MJO is supposed to be dead 2 weeks from now. The question is, will there be an active phase behind it or not? We'll see. Phase diagram charts. These are used for pinpointing the strength of the active phase of the MJO. So assume you're looking down on the North Pole. Okay, you're looking down on our planet, and the MJO, active and inactive, moved from west to east, from the Indian Ocean, over the maritime continent, into the West Pacific, underneath the United States on the equator, across the Atlantic, into North Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now, so in the, we'd say, in the western Indian Ocean. And the further the dots are away from this circle, the stronger the active phase is. So according to this, the ECMF model, pretty moderately strong active phase of the MJO in the far west Indian Ocean, scheduled to move quickly in 2 weeks, almost to the West Pacific. But also, if you're near the circle or inside the circle, it's considered to be exceedingly weak. That makes sense. That's about what we saw on the other charts. This, the GEFS model, basically says the same thing. Maybe not moving quite as far into the West Pacific and a little bit weaker 2 weeks out, but general sense of, if we can make it through the next 2 weeks, then the storm track should improve some. Take a look at the upper level model. This goes out 40 days, gives us even a longer term look. Okay, when you see the yellows, oh yes, here's the equator, here's South America, here's New Guinea, Kelvin wave generation area, basically right along in there. The yellows are areas not favorable for precipitation. So one could assume that to be the inactive phase of the MJO. You can see it's to move across the Pacific and into Central America by about the 19th of November. But we see a weak active phase starting to build in the West Pacific, fully in the West Pacific about the same time, 19th of November, so just before Thanksgiving. And then the active phase of the MJO pretty much holding in the Pacific the whole way through the end of November, and then starting to move into the Eastern Pacific. So one could say, oh, the latter half of November, Thanksgiving time frame, might be a good time for swell production. Might be, at least from an MJO perspective. And then as we get later into early December, active phase of the MJO moves into the Atlantic. Here comes the inactive phase behind that. Now, if we were in El Nino, any sort of a strong El Nino, the MJO kind of typically tends to disappear. We're not seeing that happening. There had been a lot of discussion. The model's hyping El Nino. We're not saying it's not going to form. All we're saying is, based on this and this pattern of the MJO is still somewhat to pretty much in play, and it's pretty obvious. I mean, you look at the jet stream models, clearly there's an inactive phase of the MJO in control. There's, no hope really for decent storm production. So one would say the MJO is stronger than it probably should be over the Pacific if there were some sort of El Nino developing. So let's look at yet one more model, MJO related, but also a little bit El Nino related. Okay, this is same deal. This is 850 millibar wind anomalies. That is winds up about 4,700 feet. Are they blowing more from the west or from the east? The reds are from the west. You look at this, you just go, wow, this is from August 11th, and here's the date lines right there, Kelvin wave generation right there, and you just look down and you go, it's been red nonstop, August, September. There was a little inactive phase of the MJO in early October, and then westerly anomalies continued. Here's where we are today. There's our easterly anomalies. Now, 2 weeks ago, 3 weeks ago, you looked at this chart, we didn't see any of these easterly anomalies, and there's a little bit of a hint of the inactive phase of the MJO again. But according to this, and this tends to be the more conservative of the depictions of the CFS model, about, we'll say, 5 days out, westerly anomalies start building, and as we get into mid-November, westerly anomalies are to be in control of the whole Kelvin wave generation area and holding into December. So again, this basically points to that mid-November time frame from when the storm track theoretically should start to waken up some. We're paying the price right now, but maybe we'll actually start something that somewhat resembles a real fall swell pattern by mid-November. Normally, in a good year, you'd see that in late September. Certainly by mid-October, we've been kind of saying this, we're off by a month to 6 weeks from any sort of a normal pattern, and that still appears to be the case. And yet, one more. The last MJO model, if you will, it tells us a lot more than that. This is in reverse, though. Past history is down at the bottom. The yellows and the reds are westerly wind anomalies. There's the date line running right up the middle of the picture. Kelvin wave generation area between these two tick marks going up. Here is our little pocket of easterly anomalies right today. Looks like that'll go for, in a historical perspective, this is a blip. It's nothing. And then we get into, I don't know, what's that? Probably about the 8th or the 7th of November. Westerly anomalies start building. Another little pocket just east of the dateline of easterly anomalies, but they're gone pretty quick. From here on out, it looks like westerly anomalies. This model has a bit overhyped the situation, though. It's not, it's a long-range model. It's not a super detailed one. So it was painting a month ago a stronger westerly wind pattern with strong westerly wind bursts somewhere in the mid-November time frame. All that's gone from the models now. We don't expect it to return. Let's overlay the MJO pattern. Now this, you actually see last week, I think when we did this, there were the solid contours or the active phase of the MJO. The dotted ones are the inactive. A week ago, 2 weeks ago, 3 weeks ago, these were all like single contour sort of things. Now they're starting to show two contours, two, and almost two there, suggesting that the MJO is getting stronger. Its signature is going to show up stronger, meaning that El Nino won't be as strong as what this was forecasting 2 months ago or whatever. Not surprising. Any model going out too much, there's going to be a lot of variability, a lot of unknowns. Okay, but anyway, that said, so it looks like active phase of the MJO, here we go. This is our November active phase from, let's say, mid-November the whole way into the maybe early December. Then things back off a little bit, and a real inactive phase pretty much takes over all of December into early January, and then you don't have a solid active phase again till mid-January. That's not looking particularly good at all. Let's overlay low pass filter, see what's going on. Yeah, so see these solid contours are the low pressure bias. Okay, so when people are saying El Nino, that's kind of what we're looking at. They're saying there's a propensity for low pressure in the Pacific Ocean. See, this is high pressure, these dotted contours over the Indian Ocean. That smells of El Nino. But the model's been doing this for, since August, even before July, and we haven't even really started fall yet. So, this doesn't paint the whole picture. It's some of it, but not everything. So we have to dig a little bit deeper. So what's going on in the ocean? This is the West Pacific here, East Pacific here. These little X's are the anchor lines, and these are sensors on the anchor lines of the TAO buoy array strung across the equator, 2 degrees north and south on the equator only. And what it does is it gives you sort of a profile of what water temperatures are doing in the ocean at depth. Warm water off to the west, that's pretty normal. We see the 28-degree isotherm line at 156 or so. I think that's actually moved a little bit to the west, not a lot. And the 24-degree isotherm line, I think it was back somewhere around 105, 110 last week, pushing into Ecuador or close to it now. That's good news. What this means is warm water is pushing off to the east. We can look at anomalies, differences from normal from this time of year. We know that we've been watching this. There's a Kelvin wave. What's a Kelvin wave? Ball of warm water traveling from west to east under the ocean's surface, created by the active phase of the MJO, blowing westerly anomalies in the West Pacific, takes warm water. That warm water right there taps some of it, starts pushing it to depth, and it travels the whole way across the Pacific Ocean down at about 150 meters. And it takes about 3 months to get from there to here, and this is just off the coast of Ecuador. Now, 2 or 3 weeks ago, it appeared the core of the warm water was here, like under the dateline or south of Hawaii. It's moved dramatically off to the east now, and it looks like the peak of this Kelvin wave is within a couple of weeks of getting ready to happen. And that's what we've always thought, somewhere around mid-November time frame. This is Kelvin wave, the second Kelvin wave of this cycle this year. So the point being, this warm water will eventually erupt at the ocean surface. It's actually starting to do it now and has been for a couple of weeks. And if you build up enough warm water in the East Pacific, that's the hallmark of El Nino. Here's another version of that showing, yep, sure enough, warm water. What's this? 1, 2, 3, 4, 5. 1, 2, 3, 4. So 4.5 degrees above normal in its core, basically due south of California, 120 west on the equator. And so this Kelvin wave, yeah, there's a bunch of warm water going all the way out to the dateline, but the core of the Kelvin wave's right here. A couple of weeks, it'll be erupting in Ecuador, and then things will settle down. Now, the good news here is last week and the week before, we were seeing, actually see that little blue there? We've seen some of that right over in here. So suggesting upwelling phase of the Kelvin wave cycle at least, but now we're starting to see warm water spilling. So this is actually coming from New Guinea, falling into the Pacific. It actually comes from the maritime continent. There's a bunch of little gaps in the islands over there. If you get westerly anomalies in the maritime continent, warm water will spill from there into the Pacific north of New Guinea and then start forming a new Kelvin wave. So we're keeping our eyes here, hoping that maybe another Kelvin wave will form. But even if it does in the next month, it's, you're into February, March before it ever reaches the U.S. West Coast. So this Kelvin wave is really all the fuel there is for any developing El Nino. And it looks pretty impressive here. You also see that it is erupting at the ocean surface from 100 west, so that's south of Mexico somewhere, almost the whole way out to the dateline, to beyond the dateline to 160 east. So there is fuel here in the ocean to support El Nino development, but the atmosphere sort of has to pick up on it, and the two of them have to start working together to reinforce each other. And right now, that pattern is not particularly strong. Quick look at sea level anomalies. This is the height of the ocean surface. Strip out all the waves, strip out wind waves, strip out the tide. This is from the Jason-2 satellite. See, there's a bulge of a bulge on the ocean surface, 10 centimeters high, right here, south of California at 120. So because the ocean's bulging, one assumes that there is warm water down below. Warm water, of course, expands. Cold water contracts. If there were cold water, you'd see negative anomalies here, but what we see is positive. There's New Guinea. See those islands right there? You can see the warm water seeping out, or the heights above normal seeping into the Pacific in this region here, and this is where we assume warm water is. So it's completely covering the equator over the width of the Pacific, and you also see it building up along the coast up into Baja and down towards Peru a little bit. This is a good sign. I mean, this is looking, you really want to see that kind of a triangle anvil shape pattern right in here. And we're starting to see a little bit of it, not super strong, but it gives us some hope. So let's put this in historical context, at least for the past year. December last year, cool anomalies is the East Pacific here, West Pacific here. This is upper ocean heat anomalies, upper 300 meters of the ocean surface. So you can sort of track Kelvin waves coming across. This was La Nina, little tiny weak Kelvin wave fell apart, pushed east January of this year. Upwelling phase of the Kelvin wave cycle. Kelvin wave number 1 developed February 2018. A pretty strong active phase of the MJO created it. The Kelvin wave, warm water, pushed east, eventually pushed into Ecuador in July, but not particularly strong. And then here's our stronger Kelvin wave number 2, developed in the September-ish time frame in the West Pacific. And here's where we are right now. Looks like right there, that's the upwelling phase of the Kelvin wave cycle already developing. We're hoping to see yet more warm water pushing east for the future. But all this Kelvin waves, MJOs, subsurface temperatures don't mean anything. It's what's going on the surface. And we do see, so last week we were kind of concerned because these warm anomalies on the equator, this is where the Kelvin wave is upwelling or erupting at the ocean surface here, were kind of weak. We've noticed today warming building again back along Peru. Over the Galapagos, looking pretty decent, and we'll say 5 degrees north and south of the equator. So this is good, though most of the warming is still out here at south of Hawaii sort of thing. This is not by any stretch of the imagination a significant El Nino. It's barely an El Nino as it is, and that's why you can sort of tell the jet stream isn't doing a whole lot. The atmosphere is flip-flopping. It's trying to make up its mind what it wants to do. It's clearly not in La Nina mode anymore, though it kind of still thinks it is, but it's not moving aggressively towards an El Nino pattern. So we're going to say it's basically dead. It's locked between La Nina and El Nino, dead neutral, and kind of just waiting for the seasonal change to kick off. But at least there is warm water in this area, and at some point that should help start fueling the jet stream. We look at the trend for the past 7 days. We see, yeah, good warming building along Peru, down into Chile, holding over Ecuador, and out here into the equatorial Pacific. So no cooling, that's a good sign, but just not strong warming. The overview trend, well, again, this is the main El Nino. So this is the El Nino region. The main area is from here, 120 west out to 170 west, 5 degrees north and south of the equator. Clearly, that's warmer than normal. The yellows and oranges, reds are warm. And we see reasonable warming here in this area, but not, again, just, we'll call it modest warming, something like that. So, but at least it's not cold, and cold water really stomps on the jet stream. Now, here's where things get a little bit interesting. So this is the Nino 1.2 region. This is ocean surface temperature anomalies right up along Peru and the Galapagos Islands, that sort of thing. We had a little spike here for a week, went up to about 1.3 degrees. Today, it's half a degree, 0.525 above normal. So this is speaking to the things aren't particularly warm around the Galapagos. Yeah, it's warm, but really looking at the trend, it's almost over since let's say late August. It's almost neutral, just slightly above neutral. No big deal. But the good news is, so last week we were really fretting about the temperatures in the Nino 3.4 region. They really weren't doing a whole lot. Well, this week, vast improvement. We're at plus 1.4 degrees, 1.407 above normal, but that's been it's 1, 2, 3, 4, 5 days. 5 days is not a trend make. Remember, see, we saw peaks here, and they can quickly come and go. But at least we're in the right track. The temperatures have been greater than 0 and better than a half a degree above 0 for all of October and now moving into November. But you got to do that for 5 months in a row before you have a declared El Nino, and it has to be half a degree or warmer. So we're very, very early in the game here, and pretty much even this will take for the atmosphere to sort of pick up on these ocean temperatures rising half a degree above normal. It'll take 2 months or so. So the thought is the jet stream isn't going to 2 to 3 months. Jet stream won't even wake up. Well, so let's say somewhere around early October, November, December. So maybe around Christmas time, the atmosphere will maybe start to sense that there's something going on in the ocean, and that maybe the atmosphere should respond in turn, and maybe then the jet stream will wake up a little bit. And that's kind of what the long-range model suggested too, like maybe a December-ish time frame. So we still got a ways to go. So what is going on in the atmosphere? Does the atmosphere sense that there's any warming or any sort of an El Nino thing going on? 2 indexes that we look at here. The Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When it goes negative and stays negative, that says, at a minimum, the active phase of the MJO. If it does it for months after months, then that suggests El Nino. Right now, we're at minus 5.22 for the daily contribution. But you see, yeah, we were a little bit more negative yesterday. But before that, kind of all positive. Just doesn't look anything like El Nino. 30-day average, take some of the noise out of it. You can use that to track the status of the MJO, and we see it is moving positive. That's not good. You want it to be negative. That would mean there's more low pressure over Tahiti and high pressure over Darwin. But right now, it kind of, it's not, we'll call it a weak inactive phase of the MJO. 90-day average, minus 3.58. And you go, oh, that's good. But really, you look at these numbers, it's been actually more negative than that a month ago. So really, the atmosphere is it's not going anywhere. There's no momentum. There's no swing. It's especially when you get these swings towards the negative and radically so, that's when you really get storm development. But we're just sort of hovering around neutral. It's very anemic and weak and non-committal, and just doesn't look like the atmosphere really wants to do anything at all. And then there's the ESPI index. So instead of talking about or measuring the difference in pressure between the area north of Darwin and the area north of Tahiti, this measures absolute rainfall in this area right here, okay? And this is right over the main El Nino region, right on the equator, right? There's the Galapagos, there's South America, there's New Guinea, okay? So if you have more precipitation than normal in this area, one can assume water temperatures are warmer than normal, and there's more evaporation, and the atmosphere is sensing it and doing something about it. When you get that, that's when you get El Nino, and that's when you get energy imparted to the jet stream, and that's when the storm track takes off. But what's our index today? Minus 0.32, which is basically dead neutral normal. If anything, biased drier than normal in this area, which still means that the atmosphere, even though we've got warmer temperatures building here, and we saw the Southern Oscillation Index was, looking pretty good here in terms of temperatures, we see that in terms of precipitation, the atmosphere hasn't responded yet. So until this guy gets positive, preferably like +1, and we haven't been there in 2 years, and we haven't even hardly been positive at all. We got up to +2.27 or something, like 0.27, sorry, +0.27 a couple of weeks ago. We've fallen back negative, and all this speaks to is the atmosphere just doesn't want to respond to whatever's going on in the ocean. The atmosphere still thinks it's La Nina, or if anything, just neutral. It doesn't think that there's any El Nino going on. That said, the model, the CFS version 2 model, this is forecast sea surface temperatures for the Nino 3.4 region. Official El Nino monitoring region says as of right now, temperatures should be, on average, about 0.85 degrees above normal, and that seems about right for now. The good news is the model says this is supposed to continue through, to 1 degree, maybe 1.1 degree above normal, something like that, from December the whole way through till May. That would make a El Nino out of this, and at some point, one would assume the jet stream would respond and we'd be in business. But as of right now, temperatures are following pretty close to what this model's been predicting, not too far off the mark. But right now, the ocean and the atmosphere are not coupled. That is, the ocean's doing its thing with the warm temperatures. It's kind of weak. It's not really impressive, but we'll say it's doing its thing. The atmosphere is like, whatever, I don't notice it. You got to do it a lot longer, and you got to be more forceful about it before I'm going to, respond. But if you keep producing warm water and you're steady about it, the jet stream will wake up, and then the storm track will get going. So for right now, we're waiting for fall to start, effectively. Jet stream, pretty much a mess. The models are hinting that 138 hours out, maybe we'll get a decent gale in the Gulf. That'd be great. We'll take it. Don't believe it, but maybe, just maybe. Otherwise, supposedly, El Nino's trying to get going. All the indicators are kind of pushing along in the right way. But do not get yourself too worked up over this. This is not a real El Nino. This is, at best, a modest El Nino, which means the odds can go either way. It could be a better than normal winter. It could be a worse than normal winter. But odds are, when it's all said and done, it'll probably end up being about a normal winter. The issue is, when's it ever going to start? And right now, we're just waiting like everybody else. It's going to do what it's going to do. The models do their best at projecting it, but they can make mistakes. So that's it for this week. We'll do it again next week. Same time, same channel. Get some surf while you can.